Hey, fellow mathers, the wait is over. Register today for your Building Powerful Mathematics workshop.
Y'all, registration is only open 3 times a year and you don't want to miss out.
Visit mathisfigureoutable.com/action to select your choice of workshop. You'll gain access to world-class professional development that will help you make a lasting impact in your students' lives.
You can save your spot at www.mathisfigureoutable.com/action. We'll see you on the inside.
Hey, fellow mathers, welcome to the podcast where math is figure-outable. I'm Pam, a former mimicker turned mather.
And I'm Kim, a reasoner who now knows how to... I was thinking about the fact that you said I'm Pam, not I'm Pam Harris, and I was like, I knew she was going to do that. I'm Kim, a reasoner who now knows how to share her thinking with others. At Math is Figureoutable, we are on a mission to improve math teaching.
And improve this intro to this podcast every time. Y'all, we know that algorithms are amazing human achievements, but they're not good teaching tools because mimicking step-by-step procedures can actually trap students into using a less sophisticated reasoning than the problems are intended to develop. And I am the prime example of that.
Yeah. In this super fun podcast, we help you teach mathing, building relationships with your students and grappling with mathematical relationships.
And thanks for joining us to make math more figure-outable.
Hi there.
Hey, Kim, what's up?
You know, all the good mathy things.
Some math teaching?
Yeah. I have the best review for you today.
Oh, I love good reviews.
Yeah.
Go.
Okay, so M. Madre said, love it, all caps, 5 stars. And here's the best part. I learned about this podcast from Christina Tonevald when she was speaking about lifting up other women.
Y'all, we love Christina Tonevald in so many ways.
I don't remember if it was an email or something. Maybe it was her podcast that she's talked about this. Anyway, I thought it was brilliant and wonderful. I loved it. Yep. So M. Madre said, I am an interventionist who works with students from K-5, and I'm very conscious of where they are headed math-wise. Love it. And how important connections can be to higher math. I love your strat chats and all the episodes. I'm trying to keep from binging so I have time to really digest each one. Keep up the great work. Well, thanks so much. And we are not opposed to you binging, but then it'll be slow and sad. It's one a week.
You get all caught up. Yeah, we really appreciate Christina Tonevald and the excellent work that she's done. Thanks for listening both to her. We highly recommend her work. And thanks. I wonder if it's Minnesota Madre.
Maybe.
A mom from Minnesota.
Maybe. Yeah, I don't know. Yeah, okay. Nice. So listen, today we are going to do something we've been asked about 127 million times.
Let's do it.
And we are going to talk about integer multiplication and division.
Dun, dun, dun.
Let's do it.
Every middle school teacher in the world just sat up tall and said, yes, bring it on. Bring it on.
Yeah.
All right. So we've done a little bit of work in the past, and we'll put these episodes in the show notes about the meaning of integers. And maybe I should have started with saying, I'm going to kind of give you a progression, and it's kind of a high level of progression of some things I would do, and then we'll kind of dive into integer multiplication and division.
Okay.
So the very first thing in this high-level progression is kids have to understand whole number multiplication strategies.
Mm-hmm.
So that doesn't mean that you stop the presses and you back up and you do a bunch of fact stuff from that they should have done, you're repeating that they did in 3rd grade.
Mm-hmm.
But it does mean that you could do some work with whole number multiplication that leads into integer multiplication. And the kind of work I'm suggesting is that kids are exposed to and learn the major multiplication strategies.
Mm-hmm.
So the fact that they can chunk and do smart partial products, that sort of clever chunking, or that they can do an over-under strategy with multiplication, or a 5 is half of 10 multiplication. Even flexible factoring or doubling and halving is probably the one I should have said first. So those whole number multiplication strategies are going to come into play in integer multiplication. So I think that's a really good sort of background basis. If I was a middle school teacher, I would work on those leading up to when we start working on integers. Mm-hmm. So there's the first thing. Secondly, we need to have the meaning of integers down.
Yeah.
Y'all, I remember the day when I was at Texas kind of led the way, mostly good, in kind of standards development and what it meant to have a standards progression So were some other states working on it kind of simultaneously, but Texas was definitely working on that. Here is a set of standards that you should be really working towards in these grade levels. And there was kind of this progression.
Yep.
And I remember at one of those very first kind of, here they are outlaying to leaders across the TASM is the leadership organization, kind of put it out to their leaders. And leaders said, why in the world is there a standard in 6th grade that just says, understand the meaning of integers? We just need kids to be good at the operations. And I'm going to strongly suggest that we actually do need quite a bit of work on students understand it quite a bit. Is that the right way to say it? There is work to be done to help to have students actually understand the meaning of integers.
Mm-hmm.
What do I mean by that? Now, we're going to put an episode in the show notes that we'll just talk more about that. Like if the temperature is 6 degrees above zero, then where's a temperature of -6? And putting a number line up and marking those on there. And if I'm at -15 below zero, where is that? And how does that relate to 15 above zero?
Right.
So this idea that there's distance involved and there's direction involved. And I like to even do some addition and subtraction problems with integers, but 4 kids are then held accountable for those operations to get at the meaning of integers. So I might say something like, if I'm 10 feet above sea level and I fall down a hole 15 feet, where am I? So that's kind of, it could be an addition problem where I'm adding a negative, what did I say, 15? Adding a negative 15. So 10 add negative 15, but it could also be a subtraction problem where it's 10 minus 15. And where do you end up if you do that? And then I want to draw a vertical number line and I want to have that kid fall through zero. And then bam, if I'm at 10 and I fall 15, I've landed at -15. Yeah, go ahead.
I was going to say, I don't remember if this was in investigations when I was teaching 3rd grade or if we just went there with this conversation. But I remember my students talking about like elevators and like below the ground floor. They can absolutely understand below zero if it's in context.
Yeah. And I think temperature is fantastic for that. Sea level elevation is fantastic for that. Debt is interesting, but it can be good in some circumstances. American football is not too bad if you use the line of scrimmage as zero. But definitely temperature and elevation can be fantastic contexts. I think your elevator is kind of like elevation. To get at this idea of two major things, that a negative number is the same distance from zero. You can't just tell kids that. They have to kind of experience it. Same distance as the positive number is from zero. And that has everything to do with the direction from zero. And so I like to use both horizontal and vertical number lines. Okay, that was super quick. Go listen to the other episode to get more on that.
Yeah.
So first, whole number multiplication strategies. Second, we need to know the meaning of integers with the distance. And opposite. And I got to say one more thing about that. The word opposite should come into that meaning part. So that if I'm saying something about, hey, if I'm 15 feet below sea level, where's the opposite of that? And the opposite of that's going to be 15 feet above sea level. And if you could see my hand, I just totally took my hand and I kind of reflected. I'm like, how do I do this? I'm spanning a distance with my fingers. And it's as if my fingers are on zero and my thumb is down at -15. And then I kind of reflected my hand up. So now my fingers are at zero and my thumb is at +15. So it's like this, I'm reflecting. And so I've got that vertical reflection, but also if I'm over at 13, the opposite of 13 is -13. And when I write that negative, I'm going to say the word opposite.
Yeah. So important.
Yeah. And I'm also going to talk about reflecting. So that brings in geometry. So I'm reflecting and I'm going to use the word opposite kind of along with the word negative. So I might say -5 and I might say the opposite of 5 when I write the symbol minus and 5, the opposite of 5. So those are important things to sort of start with. Third, I think we need to have kids do some operations with addition and subtraction on number lines with integers. We've done episodes on that. Go check out those episodes for more on that. Fourth, for multiplication and division, I'm going to start with multiplication. Ideally, kids have done some work on number lines with addition and subtraction strategies that I don't think you had to have, but ideally you would have because you would have wanted that for your addition and subtraction with integers. But now when we're in multiplication, when I say to a kid, hey, what is 5 times 8? We're going to do a problem string, Kim, so you're on ready.
Yep.
So if I say, what does 5 times 8 mean? What might you say? Just throw out anything.
I'm going to say that's 5/8.
So if that's 5/8, I could represent, and you might also say 40, but I'm going to represent that. And I'm just going to choose a horizontal number line for this one. I'm going to start at 0, and I'm going to make 5 jumps of 8.
Yep.
And so I'm going to painstakingly do this the first time, Kim. I'm not going to do this very often because I don't
Okay.
want to really promote all this additive thinking, but I'm going to do it once.
Okay.
So I'm going to make a jump of 8, land on 8, make a jump of 8, land on 16, make a jump of 8. Every time I say jump of 8, by the way, I'm making a jump and I'm writing 8 above it.
Yep.
So jump of 8 and land on 24, jump of 8, land on 30. How many did I say? 5?
Yeah.
One more jump of 8 and I land on, wait, where am I? 24, 32, jump of 8 and I land on 40. I think I said 30. I meant 32. Okay, so I now have a number line that has 5 jumps with 8 written above each jump with these landing marks of 8, 16, 24, 32, and 40. And then I'm like, you guys just told me that it was 40. Sure enough. So 5/8 is 40. Cool. What about 5 times -8? Now, I might put this in context where I'm saying, like, what if I had 5? I might have started the first problem with if I had 5 jumps of elevation of 8 feet. So I'm at sea level and I've jumped up 8 feet at a time, or sorry, I've jumped up, 8 feet at a time, and I've done it 5 times. Then I might say, now I'm jumped down 8 feet at a time and I've done it 5 times. Now I just said that, but I might say, like, if it's 5 times -8, what's happening here? Oh, well, you jumped down 5 times, but 8 at a time. So now, you know what? I did this wrong on my paper. I would have to erase this on the board right now and slide it over to the right because I didn't leave myself any room on the left, like a dork. Like a dork.
I knew that we were going to do some negative stuff, and so I put my 0
So
in the
you
middle.
left yourself room.
I did. I put my 0
All
in the
right.
middle.
I need more sleep or something. So yeah, the 0 should have been in the middle of my board, and then have those 5 jumps of 8 to the right. And now I would put a new number line. I'm going to do a new number line, but I'm going to put the 0 in the same spot, same lined up horizontal spot. And now I'm going to make 5 jumps to the left. And again, for the last time, I'm going to make a back, and I'm going to put a jump of -8. So jump -8 above it, land on -8. And then I'm going to say, hey, what if I make another jump of -8? Where am I landing? And they're going to say -16. And now notice how I'm, again, continuing to get at the meaning of negatives.
Right.
If I go back 8, where do I land? And it's weird that the numbers get big as I go to the left, because that's never happened before when we've been on number lines. So this is an experience, again, where we're kind of getting used to that. So now I've got these 5 jumps with -8 above each jump and those landing points. And you're telling me that then I would land on -40. Okay, cool. Then I've written the equation 5 times -8 is -40. And then we might have a conversation. Like, what are you going to think of in the future when you see something like you've seen 5 times 8 for years, but now you're going to see 5 times -8? You can think about it as jumps the other direction. Okay, cool.
So can I just say that
Yes, please.
the look of what you have on your board right now
Uh-huh.
is a beautiful look for the idea of reflection and opposite, because they
nice.
literally look like it's reflected at that 0.
Yeah, like, for example, if I look at where my 8 is and I reflect that over 0, that same distance over 0, I'm landing on where I put -8. So as a teacher, I'm really trying to make these jumps proportional so that I do get that look. So my -40 is exactly the same distance on the left of the 0 as my 40 is on the right of the 0.
Yep.
Cool. Nice noticing. Next problem in the string. Y'all, what is 6 times 7? Now, this time, I'm going to do a vertical number line. And I'm going to put 0 right in the middle. And I'm going to make 6 jumps of 7, but I'm not going to painstakingly make them all. I'm going to make them real quick. I'm just going to go 1, 2, 3, 4, 5, 6. So now I've just got 6 lumps. And I'm going to say, where is that, everybody? And they're going to say 42. And I'm going to put a 42. Now, you could tell me that your students might need one more example of seeing each of the jumps and where they land, because they're really still working on building multiplicative reasoning. And this is an opportunity for you to connect additive thinking, where I'm adding each of the factors, to multiplicative reasoning. I might believe that. I don't know that you have to at this point, but I could know your content, know your kids. If you know your kids, maybe I would do one more kind of detailed number line, especially because I just changed the direction of the number line. Now it's vertical, so I can hear that. I'm not going to today. Kim doesn't need that. And then below the, so then I'm going to write 6 times 7 is 42. So 6 jumps of 7 lands me up there at 42. Cool. Next problem. What is 6 times -7? I might have put both of these in context. I'm going up the hill, and every time I go up 7 feet at a time. Maybe this is the elevator. Every time I go up a floor, I go up 7 meters. That's kind of tall. 7 feet's too short. 7 meters too tall. Whatever. So now we're dropping, right? 6 negative sevens. I might just stay on the same vertical number line at this point for 6 times negative 7.
Mm-hmm.
Kim, what is 6 times negative 7?
Negative 42.
And how are you thinking about that?
Well, we just did 6 times 7 is 42. So I thought about 6 times 7 again and then said it's going to be the opposite.
So one way we could think about it is you've got that 42 up there, and you're like, I know it's going to be the opposite of that. I can take that same distance vertically. If you could see my hand, I just made kind of that span from 0 to 42, and then I reflected it over the 0, and now I'm down at negative 42. A fine way of thinking about that. Did anybody think about it as 6 negative sevens, where you kind of had these 6 jumps and each of them were negative 7, and bam, that would land 6 of those negative sevens would also land you on negative. So kind of 2 ways of looking at it. Interesting. I wonder how you guys might think about 9 times negative 3. All right, Kim, how are you thinking about 9 times negative 3?
Same as the last one. I think about 9 times 3 is 27.
And I'm going to go ahead and model that. This time I'm going to go back to a horizontal number line. I'm going to have 0 right in the middle this time.
But it's the opposite. So you would reflect to get negative 27.
Yeah. So this time I'm going to the left, and I'm going to do 9 jumps of negative 3. I'm making those 9 jumps just really like I'm not painstakingly putting anything above them. Just look, there's 9 jumps of negative 3. We know what 9 times 3 is. So 9 of those negative 3s is also going to land me on 27. But hey, I'm over here to the left. Cool.
So it feels to me like when you draw the jumps back.
Oh, I just modeled my strategy, not yours, huh?
Oh yeah, I don't care about that. But but that is more of an additive way of thinking about it, which might be what students do early on, to just like really hang on to that it's 9 negative 3s. But it feels more multiplicative and like knowledge of integers to say, I'm going to focus on the multiplication and then add on the integer understanding of it being opposite.
Yeah, it adds a little tricky there, and you're going to think about the multiplication. I know 9 times 3 is 27. To model your thinking, I would have put the 0 in the middle, marked 27, and then reflected it over to negative 27. And I agree with you. I think that would be a more multiplicative way of thinking about it. And so, and I'm going to ask for both of those strategies as we go.
Okay. All right.
Did you have something else?
I was going to ask if in this particular string you would want, if this is this like a first string that you would do with students?
Yeah.
So
for multiplication of integers. Yep.
Would you want both of those strategies? Is what I was going to ask. Okay.
Yes. Yes. Absolutely. Yep.
All right.
Yep. And so notice that in this problem string, I gave 5 times 8, 5 times negative 8, a pair. 6 times 7, 6 times negative 7, a pair. The next problem, I just said 9 times negative 3. And then I'm going to follow that with the last problem, which is negative 7 times 4. And the way that doesn't follow the pattern. So how are you thinking about negative 7 times 4, Kim?
Well, this one's not bad for me because I'm not thinking about jumps backwards. So I think 7 times 4 is 28. And then the opposite of that, which is negative 28.
So as you were talking, I drew a vertical number line. I put 0 in the middle. And when you said 7 times 4 is 28, I marked a distance up of 28. And you said, then I'm going to take the opposite of that. And I made motions with my hand to reflect over the 0. And I'm like, oh, so down here at negative 28. That would definitely be a great strategy. Yep. I'm not done. Yeah, go ahead.
Go ahead. Well, I was going to say, I think this might be where teachers, students run into a little bit of a tricky situation, because if they're thinking additively, how do you do
negative sevens of anything? Yeah, absolutely. So if they're thinking additively, I am going to try to ask questions that nudge them towards 4 negative sevens. The problem was negative 7 times 4.
Yeah.
And I'm going to maybe say something about the commutative property. Can we think about this as 4 negative sevens?
Yeah.
But I'm going to also really think about this reflection part.
Right.
Yeah. So can we really think about this as 7 times 4 and the opposite of that?
Yeah.
And at the end of this string, I might write that negative 7 times 4 as negative, probably negative 1 times parentheses, times a quantity, 7 times 4. And I know a lot of teachers do this, but I think they kind of do it first. I'm going to invite you to do it after you've done the kind of experience that we just did. So that's a way of modeling algebraically what Kim's kind of been thinking about. She's thinking about negative 7 times 4 as the opposite, that negative 1, times 7 times 4. And so I'm sort of thinking about the 7 times 4 first, and then I'm taking the opposite of it. And we're also adding in this maybe new idea that we're reflecting. If we know where 7 times 4 is, we're reflecting that over the 0.
Yeah.
But we've built that kind of from the additive way of kind of reasoning about the 4 negative 7s, and also and connecting that to this idea of thinking about the opposite and the negative, of the positive product.
Yeah.
I can talk. Cool. All right. So that's a problem string to get kids kind of thinking about at least a positive times a negative.
Right.
All right. So, God, this is going a little longer than I was hoping. So let's see how this next one goes. So, Kim, let's do one more quick string.
Follow-up string.
Follow-up
Nice.
string.
Two for one, teachers.
There you go. So I might start this string with, hey, everybody, 8 times 3. When they say 8 times 3, then I'm going to go ahead and model it as just 8 times 3 without the jumps.
Okay.
Depending on the class that I have, if I think I need to do the jumps one more time, I might. But today I'm just going to say, hey, if you have 8 3s, you guys are telling me that that's landing on 24. So I'm going to mark the 24, finish the equation, equals 24. Then I'm going to say, what is 3 times negative 8?
Oh, that's the opposite of, it's 24. 3 times 8 is 24. And then the opposite of that.
The opposite of it. And so I'm going to again ask for both strategies, because I think I'm going to have kids that are also thinking about 3 negative 8s. And so I'm going to say, all right, if I have a jump of negative 8, negative 8, negative 8, I would land on negative 24. Oh, and I also have this sort of reflection opposite thing happening like we talked about last time. Cool. So what if I have negative 3 times 8? I'm not going to spend a lot of time in the podcast on that, but I would have the same conversation that we just had where we had negative 7 times 4. Can you think about that as opposite? Can you also use the commutative property? Go ahead.
Well, no, go ahead and finish. I want to say one thing.
Okay. So two major things coming out. Can we use the commutative property to think about 8 times negative 3 or 8 negative 3s? What would that look like on a number line? Where would we mark it? Can we also use sort of the Kim strategy of thinking about just the opposite of 3 times 8? So I'd want to make sure both of those come out. Go ahead.
Yeah. So the two problems you put in a row I really like, because if you're thinking about the fact and then the opposite, then you have 3 times 8, the opposite of it, when you have it with negative 8, and then it's the same thing, right? So the two problems, 3 times negative 8 and negative 3 times 8, are equivalent.
Yes.
But the negative is with each of the factors.
Yeah, nice. And then I might write that algebraically as with that negative 1 outside the 3 times 8, the quantity of 3 times 8. Cool. And then you'll notice that we just whipped through that because we're having the same conversations that we would have had in the previous string. So this, I wouldn't necessarily do this in the same day. This is me coming back tomorrow and saying, hey, remember we did yesterday? That's why I'm kind of getting back into the conversation. Next question in the string, what is negative 3 times negative 8? Now I'm going to pause on this one a little bit.
Yeah.
And wonder if we can think about that. Hey, there's probably one more thing I should have said in the problem before, now that I'm here. When we had negative 3 times 8, and we wrote that negative 1 outside the 3 times 8, I wish I would have said, so we really are agreeing now that we can say, if we've got negatives involved, we can think about the product, and then we can think about the opposite of that product. Okay, so now that we have negative 3 times negative 8, I'm going to let kids think a little bit, and I'm going to wonder if we can use this idea of opposite. Kim, what are you thinking about?
I'm thinking about 3 times negative 8 is negative 24.
Okay.
There'll be 3 of them. And then I want the opposite of that product because I have another negative 3.
So it's almost like you could pull out a negative 1, but only 1, right?
Yep.
And then you're like, well, so 3 times negative 8, I can think about that. That's 3 of those negative 8s. We've been doing that. It's like 24, the opposite of that. But I still have then another opposite happening.
Right.
And we can then reflect that. So we can actually sort of look at there's our 3 -8s. Go 3 jumps of 8 from 0. But now I have the opposite of that. Where have we all agreed where that is? Bam, that reflects over the 0, and we end up with positive 24.
Yeah.
Huh. You guys think that's going to work every time? I would repeat that same idea with 7 times 8. So do something like, and should I say it now? Later. I'm going to say it now so I don't forget. You might notice that some of the facts that we're using are some of the most missed facts. Now,
yeah.
I did 5 times 8 at the beginning because actually that's not such a missed fact. Kids often can think about 8 5s, but I did it as 5 times 8 because I wanted them to use maybe what they know about 8 times 5. So 40 is not too hard. But the rest of these are all sort of facts that are not necessarily ones that kids just have on their fingertips. This last set of problems is going to be 7 times 8. That's a way, middle school teachers, of helping your kids get better at their single digit facts while you're doing integers. It's not just saying, well, if you know your facts, then this integer stuff would be easy. It's like, no, let's actually give you experience with these often missed facts while we're learning the integer stuff. So that's a purposeful move.
Yeah. I want to call out specifically the progression that happened.
Okay.
Because you started with a basic fact, 5 times 8. And then you kind of let the relationships unfold. So you went with one negative where they could think about it additively. Then you thought about another negative that then they would maybe move in towards thinking about opposite. You talked about some commutative property stuff. And then the last layer was with 2 negatives, -3 times -8. What you didn't do was say, hey, Kim, negative times a negative is a positive, and we're going to give you a worksheet where you just put negatives wherever you want, all over the place, sometimes 1, sometimes 2, sometimes none. Ready, go.
Apply the rule. 1 negative, it's negative. 2 negatives, a positive. Go.
Right. What you're doing here is building the big idea of equivalence. When we talk about 3 times -8 or -3 times 8, that's a huge idea for kids that they're equivalent. We're understanding opposite, which will continue to be huge. And, kids aren't going to regurgitate 2 negatives make a positive. Because
especially when they're adding.
Right.
They're adding and
-3 and -7, not 10. And that's where they start messing things up, right? They try over apply and apply the wrong time.
Misapply. And
yeah,
exactly. Yeah, I hope this gives everybody an example of what it means to actually develop relationships rather than give a rule and practice.
Yeah. Okay. Big takeaways.
Big takeaways. A whole number multiplication is going to be helpful. The meaning of integers is super helpful, where we're going to talk about distance, reflections, and opposite. And do that with addition, subtraction, and then make sure that we've got some jumps on number lines where we're using those reflections and opposite every time we see the negative, and we're using equivalence and the commutative property and again opposite to make sense of those reflections.
If you're listening to this episode and you're like, that's great, but my kids don't know their facts, then we'd also like to suggest that work can be done in the midst of these strings. But we also have a free download for you that you can check out. It is mathisfigureoutable.com/facts, PS, like fact problem string, mathisfigureoutable.com/facts problem string. And also at the beginning of the episode, Pam talked about major strategies for each of the multiplication operations. I don't think you mentioned other ones, but you can find out what the major strategies are with a free download, mathisfigureoutable.com/big. It's a big ebook.
It's a big idea.
Yeah.
Check that one out. All right, Kim, awesome. Thank you for tuning in, everybody, and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. Did you hear the announcement? Workshop registration is open.
It's in these workshops where you will learn all the things that you need to make math more figureoutable. Select your workshop at mathisfigureoutable.com/action.
Hey, kindergarten through 12th grade educators, we have a workshop for you. Build your numeracy, learn the teacher moves, equip yourself with the knowledge you need to have students naturally engaged in their learning. No matter what grade level you teach, we have a targeted workshop for you.
Find your best workshop for you at mathisfigureoutable.com/action.
Let's change the world together and make math more figureoutable.